We'll be looking at how we can calculate a magnitude of a vector which is given in vector notation. Let's say vector A, which is ax I cap plus ay j cap plus az k cap, is given, and we have to find its magnitude. As we know that the magnitude is length of this vector, so we can say this is nothing but ax square plus ay square plus az square whole root of that. Now I'm going to prove this, that this is nothing but the length of the vector. So draw a cuboid. Of dimensions x, y along the directions x, y and z as shown. So let's say this is x-axis, this is y-axis, and this is z-axis. So this length is ax for the given vector, this length is ay for the given vector, and this length is az for the given vector. So if we use the vector as this is ax I cap, this is ay j cap, and this vector is nothing but az k cap. So we are getting a vector from this to this, which is nothing but the sum of these vectors. So this vector is ax I cap plus ay j cap plus az k cap, and that is the diagonal of the cuboid. So we can say diagonal of the cuboid is nothing but sum of squares of individual sides whole root of that. Okay, so we can get the magnitude of this vector. Let's take some examples in which we have to find the magnitude of vector. Vector A is given by I, single I cap, 2 j cap plus 3 k cap. So as the x component is 1 square, y component is 2, so square of 2, and z component is 3. I'll take the root of that. So we get 9 plus 4, 13 plus 14, root of 14. Similarly, in the next example, x, y components are 1, minus 2, and z component is minus 3. But as we are doing the squares, whether it's plus 3 or minus 3, doesn't matter, we'll get the same, root 14. In the next example, there's no j cap, or we can say the y component is 0. So magnitude of vector B, I have just given another name, B vector will be square of x component plus square of y component, which is 0, plus square of z component, which is minus cos theta, and whole root of that. As we already know, sin squared theta plus cos squared theta is 1. So this is vector of magnitude 1 unit. We can also call it B cap. Any vector which is having a unit magnitude is called unit vector. So what about vector A? The magnitude of this is 1 by root 2 square is 1 by 2 plus 1 by 2 plus 1 by 2 whole root. We are getting 3 by 2 and root of that. So in this way we can find the magnitude of vectors. Let's take few more examples. In this, vector A is 1 by root I minus 1 by root 2 j. So the magnitude of A is 1 by root 2 square plus 1 by root 2 square and whole root. So it will be nothing but 1 by 2 plus 1 by 2 is 1, and square root of 1 is 1. And in this we can easily see that the magnitude will be 1 by root 3 square plus square of minus 1 by root 3, which is same as 1 by root 3 square, again 1 by root 3 square, root of that. So again we are getting 1. So these are unit vector. This is also a unit vector, this is also a unit vector, because the magnitude of their resultant is 1. So if we try to find out the magnitude of this vector. It is nothing but 2 square plus minus 2 square plus 1 square root of that. Just take care of this negative sign. It will not create any difference whether it's positive or negative because we have to take the square of that. Okay, so it will obviously add and will never become 0 or negative. So we are getting root of 9, which is 3. Similarly, in this 1 square plus 1 square plus square of minus 1 whole root. So we are getting root 3. So these are the few examples in which I have calculated the resultant or the magnitude of vector. In the next question, we have to find value of C if vector A is a unit vector. So vector A is given like this. If vector A is a unit vector, then magnitude of vector A must be 1. So we'll find the magnitude, which is 0.8 square plus 0.2 root with a minus sign square of that. This is the y component and z component is c. So this should be 1. By solving it, we are getting 0.64 plus 0.2 plus c square is equal to 1. Hence c square is nothing but 0.84, 0.16 implies c is 0.4. We get the value of c as 0.4. The value of c can also be minus 0.4. As c square is 0.16, we are getting two values of c as plus minus 0.4. Similarly, we can take few important observations that magnitude of A must be greater than or equal to AX or AY or AZ. So the magnitude of vector will be greater than its component, or at max they can be equal to that if other two is 0. So if two components, say x and y, are 0, then only AZ will be equal to magnitude of vector A. Otherwise, each component will be smaller than the magnitude of whole vector because ultimately they will add whether they are negative or positive components.